Welcome to the SecuredMe Educational Suite. This is a complete ecosystem of 10 specialized tools designed to work together to create a safe, AI-assisted learning environment for students and educators. In this guide, we will walk through exactly how this system operates. First, we will follow a student using 7 interactive mini-tools to build and test their projects. Then, we will switch perspectives to show how a teacher uses 3 governance tools to review and publish that work. Before anyone writes a line of code, we have to establish the school authentication boundary. Local .env files and raw API keys are strictly forbidden. Instead, all external access relies on browser WebAuth, ensuring that unguided models cannot bypass permissions to access student data or school infrastructure. This strict authentication path prevents raw token leaks and ensures all model interactions are tied to a verified session. By locking down these secrets, the environment remains a deterministic sandbox where experiments are logged and authorized. Step 1 of the student journey begins with architecture. Here, learners open the Visual Algorithm Designer and the Algorithm Builder app. Instead of blank text editors, students drag and drop prefabricated logic nodes onto a canvas. They wire a standard ML Classique node directly into an anomaly detection node. The system then returns a coherence score, giving immediate, deterministic feedback. This visual building phase allows learners to grasp abstract pipeline architecture before they face the financial costs or cybersecurity risks of a live coding environment. With the design approved, the student moves to testing. They bring their logic into Quanthor, an environment that solidifies the underlying math through formal verification. Quanthor routes Mizar language drafts directly into local Docker containers. Because this happens locally, the system catches mathematical errors through rigid proof checking, completely avoiding the risk of external AI hallucinations. From there, the student applies their logic against specialized datasets. They use Cynthia for biological taxonomy and source traceability, or plug into VOT Guardian to test audio fraud detection models. When working inside VOT Guardian, there is a strict safety rule. Any audio risk label the student generates is an artifact for review. It must never be treated as an automated accusation. When VOT Guardian generates a risk score, the student must reconcile that number with the signal quality and missing context. This process reveals that algorithms offer evidence for a decision, rather than making the decision themselves. For advanced projects, the pipeline extends into wave propagation and quantum simulation, using the FNP-QNN quantum simulator and the Tesla Resonance Recovery Workbench. To navigate these complex spaces, the suite introduces Qubit the owl, representing the intellectual curiosity needed to break down high-level physics into approachable steps. Following Qubit's guidance, the student uses educational circuit diagrams to visually track deterministic gate traces. This final layer of verification ensures the quantum model behaves exactly as mathematically predicted. That completes the student workflow. They have authored a fully built, mathematically verified, and boundary-tested project that is ready for submission. Completing this advanced verification shifts the student's focus from following prompts to auditing the internal state of the simulator. Now the perspective shifts to the educator's workflow. The teacher starts with FedQLC, which acts as an evidence gate, checking the student's submission for structural admissibility and valid runtime proofs. Once the technical proofs pass, the teacher opens Market Guardian, also known as Retail Guard. This acts as the primary review workbench for assessing the situational ambiguity and the real-world evidence of the student's scenario. Guided by Vigil the Links, this phase reminds educators that evaluating data requires active listening and careful signal detection rather than rushing to a verdict. Using the Educational Marketing Plan template, the teacher audits the documentation. They verify the project strictly adheres to its defined ethical boundary constraints. This establishes the core philosophy of the suite. Large language models are not the authority for facts. The teacher's deterministic reconciliation of the evidence is what actually validates the student's comprehension. When a project passes all reviews, it reaches its final destination, the SecuredMe Scalarium. The teacher moves the verified white paper into this Omega-themed research commons. Here, the student's work is officially recorded as a public pre-alpha research note, completing their academic journey. However, there is a hard limitation. Using any part of this suite for commercial accusation, live monitoring, or real-world enforcement directly violates the Secured Educational License. To set up your own compliant classroom, clone the repositories from GitHub, initiate local Docker instances, and review governance documents before bringing students online. By integrating technical implementation with an audit layer, the suite requires students to document their ethical boundaries alongside their code. This structure prepares learners to defend the logic of their systems in a supervised setting.